to moles to atoms, okay? We're going to look at the basic unit first. We're going to look at the compound second, and then we're going to look at the double compound stuff, okay? Or the compound versus the element. Look at. So the first thing you want to do, let's look at a problem. 3.00 grams of, it says, boron, tribromide. So the first thing you want to do is figure out how to balance a little nomenclature study. We're going to have boron, tribromide. What do you see first here? A prefix, which is going to tell you what? Covalent. So do we have to worry about balancing it? No, it's already balanced. So it's going to be boron and then tri meaning 3. So bromine, or boron and then bromine and then 3. Make sense? Okay. So now we know we have 3 grams of that stuff. Okay. So if I wanted to create a roadmap, I would do this, okay? I would go there and put what I know now into my roadmap. So I know I have 3 grams of BBr3. Now the first thing I want to ask is, how do you go to moles? Okay? How do you go to moles? So the first thing I want to know is, where am I starting? Grams. If I'm going to moles, I'm just going to do 1 hop over. Okay? So let's start with what I know. So grams of the BBr3. And y'all, somebody's going to have to get their calculator ready because I need some multiplication to do that. Alright, and then on the top of the next section will be moles of BBr3, right? Once you finish up with your moles of BBr3, now have you gotten to your stopping place where you want to go? Yes, because where am I going? Moles. So what will go on bottom? GBBr3. Alright, so we've got the GBBr3 times mole BBr3 over GBBr3. And now I can fill in what I know. How many grams of the stuff do I have originally? 3. Do you see why it's important now to put the number above the little square there so you know where you're going? Okay. So once you finish that, now it's just to figure out what goes with mole, what goes with gram. What always goes with mole when we're looking at these kind of 1. And what will go with the gram? Something off the periodic table, right? So molar mass. Let's look at the molar mass solid for it. So bromine and boron, okay? We've got 1 of these and we've got 3 of these. If I wanted to look at boron, it's 10.81. Off the periodic table, and bromine is what? 79.1. So boron is going to be obviously 10.81. Somebody do the math on the next portion and get it for me. 3 times the 79, 91. 239.73. That would make sense. All right, then what is it when we add it all together? 4, 15, 10, 250.54. Is that right? Yep. Okay, it's grams of mole of BBr3. There you go. So now you've solved for the molar mass. You just plug that into the equation and multiply it out. And then our answer is going to be 3 divided by 250.54. And this cancels, and this cancels, and you're left with what? 0. What? 0.12. And it is in moles of BBr3. Okay, so if I wanted to go to atoms, I wouldn't have stopped here. I would have went 1 step further, right? If I want to do that, it's going to be exactly the same thing set up. So now I just rewrote what I knew. I'm going to go find moles of BBr3. So moles of BBr3 here. And I've got to go to where? Atoms. So what's going to be on top here? Atoms. Okay. And what will be on bottom? Moles. And we do know that atoms are actually molecules because it is a compound. But for us to win our problems, the GMA works the same way. We're going to just call it atoms for right now. So 1 goes with the mole. Atoms will be what? Avogadro's number, which is what? 6.022 times 10 to the 23rd power equals. So basically you're going to say 3 times 6.022 times 10 to the 23rd power divided by 250.54 equals, and you should get the amount of molecules or atoms of that, well, molecules of BBR3. Anybody got it for me? I got somebody that said 7.21. Is that about right? Anybody else get anything different? Times 10 to the 23rd power? 21st. So times 10 to the 21st power. Does that make sense? Okay, I'll give you a little piece of advice. If you see 10 to the 49th power on any of your equations, you probably have done something wrong, because normally you'll see it 10 to the 21st, 22nd, 23rd, 10 to the 24th, 25th, maybe around those numbers. But the 10 to the 49th power is pretty much saying that you've doubled up somewhere and multiplying the atoms together times atoms. Okay, so that's how you do basically like a GMA problem with a compound. Yes, sir. So basically you've done a GMA problem with the compound itself. Okay, if you were doing it for boron by itself, it would be exactly the same way, except you just get the number, would be the molar mass or the number off the periodic table. If it's just boron. If I said I had 4 grams of boron, could you go to moles?
Yes.
By using the periodic table number or molar mass number? Periodic table number, right? Because it's just the element, okay? So that's how you do that. Now, let's just say I wanted to know how much bromine we're in this problem, okay? Bromine. And I want to know the grams of bromine. So now I'm not looking at moles of the stuff anymore. I'm looking at grams of BR. So now we're going to restart the roadmap. And we're going to use exactly what we've already used to an extent. Okay? So we know that we get here. We're going here. So we go over one hop, we come down one, and then we hop again. Okay? Now, anytime that we're in this little square right here, what does that mean to us? That means that we're going to have that little weirdo piece that's like moles of the big stuff to moles of the small stuff, right? So let's start off. What do we have first? 3 grams of the stuff, right? Somebody tell me what we're going to multiply by. What's on top? Moles of the stuff. Now we're going to multiply it and go to moles of bromide, or bromine for this example. We went to moles of bromine. Now we're going to go to grams of bromine. And our goal is to get up to grams of bromine, right? Okay, so now what I have is basically my roadmap ready to go. So now I got to put one on the bottom. Bring everything down. So what's going to go here? Okay, what's going to go here? Moles of what? BBR3. What's going to go here? Now, every time I see mole and gram or mole or mole or atom or mole, you know that there's going to be a 1 with the mole automatically. So here we have 1 and here we have 1, right? Okay. Now I need to know about the gram weight. When we start talking about gram weights, we know we go on the periodic table. So if we're looking at a compound, we're looking at molar masses, right? The whole thing together. And if we're looking at, we're just looking at an element by itself, we're just looking at the gram weight straight off or the gram mass straight off the periodic table. That'll help us think about it. So BBR3, we need the molar mass, or we're going to look at just the number off the periodic table. Molar mass, which is up there, is 250.54, right? We're going to skip this section right now. We're going to go over here. How many grams is BR? Well, we know it's what? 79.91. Now let's look at it. What's the big stuff? Is it going to be BBR3 or BR? BBR3. So we know that we have 1 understood mole of that stuff, right? Because it's the big stuff. We know that. That's how we get that 1 there. Now we need to know how many of the little thing is in the big thing. So let's go back over to the molar mass and look at BR. BR has how many There's 3 moles in it. So when we multiply that out, we would have something that has 3 times 3.00. Let's get that right. 3.00 times 1 times 3 times 79.91 divided by 250.54 equals. Now somebody can put that on their calculator and figure that out for me. We would be left in grams of VR. Let me get on the calculator yet. Okay, someone says 2.9. I hope that's right. Is that right? Somebody else said it's right? Sorry, ma'am. It's 2.81.
What you got to round?
It's 2.87 what? Okay, so if this is the answer, and if I were rounding it to 1 decimal place, that would be the answer. But we like to look at 2 decimal places just for us. For right now, I'm not looking at significant figures. So it'll be 2.87 grams of VR. Is that what you got? Anybody else do it? Yeah. That's what you got? Okay, and that's how you solve a double GMA. You can stop.